This is Algebra 2, Concept 17. I'm looking at numbers 7 and 8 in this video, where we're looking at this sigma notation. The directions say write out at least 4 terms of each infinite geometric series, then find each sum using the formula you derived in number 6. Now, we'll go over that formula in a moment. If we look at number 7, our sigma notation tells us that they want the sum from 1 to infinity, literally every number possible, of this geometric series. Now we're starting with 4 as our 0 term times 3/5 to the n minus 1 power. Now, they're saying the first 4 terms, so this would be the first term, second term, third, and then fourth there. Now for the first term, what we're saying is that we're going to take this n value of 1, plug that in here. So it becomes 4 times 3/5 to the 1 minus 1, whoops, which is 3/5 to the 0. Anything to the 0 power is just 1, so it's 4 times 1, or just 4. So the first number in the sequence is 4. If you notice that I've been writing as the bell rang, 2, now I'm plugging in 2 for the second term. Subtracting 1, I get 1. 3/5 to the first power is 3/5. Now when I multiply these fractions, multiply straight across, and I get 12 over 5. There's my second term. Third term, same thing. 3/5, 3 minus 1 this time, which means it's 3/5 raised to the second power. When I square 3/5, I get 9 over 25. Multiply straight across like last time. Excuse me, I get 36 over 25. Now, to save yourself some time, now what you're doing is you can take each of these and you're just really multiplying by 3/5. So if you multiply this by 3/5, you get this. This by 3/5, you get this. By 3/5 again, multiplying by 3 up top, 36 times 3 is 108, times 5 on the bottom is 125. So our excuse me, our fourth term is 108 over 125, and you would keep going forever and ever and ever. Now the sum is where we have to use that new formula. So for the new formula, I'm going to use S for sum, is a sub 1 over 1 minus r. A sub 1 is the first term, which we just found, and the r is the multiplier. That's what you're multiplying by each time in the geometric series. So for this example, if I plug into A1, my first term is the 4, so it's 4 on top over 1 minus, the r is the 3/5, there's my multiplier, 3/5. Then I had to work this out, and it really just comes down to working this out whether you know how to work with the fractions. Remember that 1 whole is the same thing as 5/5, so I can get rid of that, which means it's really 4 divided by 2/5 when I subtract those. So now going old school, I'm going to use the old school division, 4 divided by 2/5. This is 4 over 1. I keep the 4 over 1, this changes to multiplication, and I flip this to 5 over 2. When I multiply those, I get 20 over 2, 4 times 5 for the 20, 1 times 2 on the bottom, and that divides to give me a sum of 10. Now number 8, very, very close to what we just did. They don't have a number out front, so we're going to go ahead and just plug in the 1 right away. So I'm going to move these, fold these notes, and then do this there. Bring this back up here. So then to get the first term, I'm just starting with 1/2 to the n minus 1, but again I'm plugging in the 1 here. 1 minus 1, that's 1/2 to the 0 power. Anything again to the 0 power is 1, so my first term is 1 whole. Now this, to get the rest, remember that all we're doing is we're multiplying by 1/2 now. This times 1/2 is 1/2. This times 1/2 is 1/4. Times 1/2 again, 1/8. Next one would be 1/16, and then 1 over 32, and so on. Then the sum, again, reminder, the sum is a sub 1 over 1 minus r. We just found a sub 1, that's the first term, that's the 1. 1 minus, instead of r, now we're multiplying by 1/2 each time, so that's 1/2. And here, many of you can probably do this without getting the common denominator. We know 1 minus 1/2 is just 1/2, which means that this then becomes, like before we wrote it old school, get rid of that, equals 1 divided by 1/2. This is 1 over 1. Oh, sorry. And then 1 times 2 over 1, which just gives us a 2 for our sum. So there's our two sums for number 7 and 8.